Good morning, students. Welcome to Maths Camp. We are doing this chapter of 9th standard surface area and volume. We have already studied about the formula of cube, cuboid, and right circular cylinder. The latest we saw was right circular cylinder. So we'll just revise the formula of right circular cylinder and we will do few more questions from our chapter number 13 surface area and volume based on right circular cylinder. Okay, so let's first revise the formula. I hope you remember the formula. Okay, there were three formulae. First was the curved surface area or the lateral surface area we used to call it, and then there is total surface area and volume. So we have this formula where the first formula is lateral surface area. The formula is 2 pi RH. You can just read this formula as this 2 pi r means the circumference, isn't it? 2 pi r is the circumference of a circle. So it is circumference multiplied by height of the cylinder. So we get the lateral or the curved surface area of the cylinder. The next formula that we have is total surface area. Now when we say total, we have to add surfaces, surface areas of all the surfaces. So there are total 3 surfaces, one lateral surface, that is a curved surface, and 2 circular horizontal surfaces, or we can say circular surfaces. So when we add them, we get this formula 2 pi r into r plus h. This is a formula for total surface area. The third one is for volume. Now volume is, for such objects, volume is area of base into height. Now area of base, since base is circle, so it is pi r square multiplied by height, so pi r square h. So these are the three formulae you should know when you solve questions based on right circular cylinder. Now here you can see the value pi. Now pi is a constant. We will mostly take it, or most of the time we'll take it as 22/7 unless it is specified otherwise. In few questions they may specify it as 3.14. If it is given in the question to use 3.14, we use 3.14. Otherwise we use 22/7 every time. Okay, so let's see the questions based on this. In the last session we solved question number 11 of 13.2. That was the last question that we did. Now we'll solve this 13.2 question number 3. Okay, this is a very interesting question. It is very much application based question. You can connect to the real life problems also. Now the question is, a metal pipe is 77 centimeter long. The inner diameter of a cross section is 4 centimeter and outer diameter being 4.4 centimeter. Find its inner curved surface area, outer curved surface area, and total surface area. So as we can see here, we have a pipe. Now remember, we don't have a solid cylinder, we can say. We have a cylinder which is hollow. When we say pipe, it has to be a hollow cylinder. So as you can see in the picture also, we can see there is a hollow cylinder. It is not solid. Okay. Now what we have to find? We have to find out the inner curved surface area. Okay. We have to find out the outer curved surface area, and we have to find out the total surface area. Okay. So let's see how to get this inner, outer, and total surface area. So when we solve these questions, remember, we have to see the dimension that we can see. In the question it is mentioned, it is 77 centimeter long. Now usually with respect to a cylinder, we don't say long, we use the letter H and we say height of the cylinder. Okay, but here in this case, since it is a pipe, if it is kept horizontally, it will become the length. If you keep it vertically, it will be height. So in case of a cylinder, the length and height means the same. If it is mentioned as height or as length, we use the letter H for it, and it is the same. Length and height of a cylinder is same. Okay, so when we solve this, let us solve this. I want all of you to solve it with me, and you will be doing all the calculations by yourself. So we'll first note down the information that we have. So what we have, we know that it is 77 centimeter long. That means length of the pipe. But remember, we use the letter H. So note down this. Length of the pipe is 77 centimeters. Now, since the pipe is hollow, it has two types of radii. दो तरह का radius है इसका. When we see The cross section, you must have heard this word horizontal cross section. So we have a horizontal cross section here. So we have this cross section, and we can see in the figure the diameter of the outer section is 4 centimeter. I'm sorry, the inner section, diameter of the inner section is 4 centimeter. We are always interested in the radius. So we'll consider the inner radius. It is going to be small, so we have used the small letter r. So inner radius small letter r is equal to diameter divided by 2. So it will be 4 upon 2. We get the radius, inner radius, that is 2 centimeter. Same way we know that outer diameter being 4.4 centimeter. Okay, now if outer diameter is 4.4 centimeter, we can calculate the outer radius. We'll use the capital letter R for it. We get outer radius as 4.4 upon 2, which will give us 2.2 centimeter. Now we know radii and the height. So let's find out the surface area. The first question is inner surface area. Now understand it is inner core surface area. We can see that when the cylinder is solid, we can see the outer part, that is the lateral surface area, the outer core surface area we know. Same way it will form inner core surface area because it's a hollow pipe. But to calculate the inner core surface area, okay, we have to consider the inner radius. And when we calculate the outer core surface area, we have to consider the outer radius. The formula for core surface area is 2 pi RH. But here, since it is inner surface area, inner core surface area, we have to consider the inner radius, that is small letter r. All right. So let's just write down the statement. Inner core surface is equal to 2 pi RH. Okay. And then we will calculate this. So when we write down this formula, inner core surface area, it is 2 pi RH. Remember, the radius is going to be small letter r, that is the inner radius. So we have 2 into 22 upon 7 multiplied by 2 multiplied by the height, the h. We know that the length of the pipe is height of the cylinder, so it is 77. Okay, I'm giving you a minute, I'm giving you 30 seconds. You calculate this and tell me the answer. Do this multiplication and tell me what is the answer we are getting. Janvi has given me the answer. Muskan has given the answer. It is surface area. Okay. Bhavandana has given me all the answers. Okay. Let's see. The first thing that we'll do here, we'll calculate this 7, 11, the 77. वो cancellation हो जाएगा. And then it is simple multiplication. 2 into 22 will be 44. 44 into 2 will be 88. 88 into 11. वो आपको करना पड़ेगा. 88 into 11 हो जाएगा. 2 into 22 into 2 into 11. That is 968 centimeter square. 968 centimeter square. विहान आपने एक मल्टीप्लिकेशन आपको और करना है. One number you have to multiply more. You have to multiply by 4, I guess. You do 11 into 22 first. Now you do 4 multiplied by 4. Okay. So here we get the inner core surface area. Inner core surface area is 968 centimeters square. Okay. That's our first answer. I hope since we have done the first answer, it is going to be easy for you to get the second answer also. So let's do the second part. The second part says outer core surface area. Exactly the same formula, but different radius will be used here. So the formula is again, core surface area is 2 pi RH, but the radius here will be capital letter R. So write down outer core surface is equal to 2 pi RH. Go ahead and calculate this. So we have 2 multiplied by 22 upon 7 multiplied by 2.2 because the outer radius is 2.2, and h, that is the length of the pipe, which is the height of the cylinder, will be again 77. Same way we have to calculate, do this. So again, 7, 11 the 70, 77. The only difference here is instead of 2, we have 2.2. So we just have to take care of that decimal also. Okay. So we can first multiply 2 into 22 into 2.2 into 11. Just do this calculation. Answer will be in decimal, obviously, because we are multiplying it by 2.2. Okay, I'm waiting for your answers. So the multiplication here will be 1064.8 centimeters square. Okay, 1064.8 centimeters square. So that's the outer curved surface area. So we have calculated the inner curved surface area and the outer curved surface area. Now understand the third part, which is the most important one here. We are done with first and second. Let's see the third part. The third part says total surface area. Okay. Now we have already studied when we talk about total surface area, we do addition of all the surfaces. हम सबको add करते हैं, ठीक है? Just understand that. When we have solid cylinder, we add all the surfaces. Okay. So when we talk about total surface area, remember it is addition of all the surfaces. Okay, it is addition of all the surfaces. In case of a solid cylinder, what we do? We take the curved surface area. Okay, the area of the top and area of the base. Area of two circles plus curved surface. We add three surfaces. Now look at this object carefully. When you talk about total surface area of this pipe, how many surfaces do you see here? First of all, how many surfaces do we have for this object? Just observe it carefully. Imagine a cylinder which is hollow. How many surfaces it will have? Come on, give me the answer. How many surfaces will be there? Okay, Ketki has given me the answer. Ketki saying 4. Sayyam has given me the answer. Remember students, in case of a solid, okay, in case of a solid cylinder, we have 3 surfaces, but it is not solid. It is hollow from inside. So there is one additional surface here. There will be total 4 surfaces. Now see, 2 of them we have already calculated. Now remember, there is an inner curved surface area that we already know, that we have already calculated. There is an outer curved surface area that also we have calculated. Okay, but other than the inner curved surface area and outer curved surface area, look at this bases. जो base है ना इसका ये, the top and the bottom. See at the top, it is not actually a circle, but it is like a ring. ये जो ring आप देख रहे हो ना, it will also have some surface, right? इसका भी surface area होगा, the ring that you can see. Okay, so you have to add the area of the upper ring and the lower ring. Okay, so you have to add area of 2 bases also. In case of a cylinder, we used to add the area of 2 circles, but here it is not entire circle, it is just a ring-like structure. Okay, so हमें दोनों rings का भी area add करना है. So total there are 4 surfaces. The 2 areas we already know. Inner curved surface area we know. Outer curved surface area also we know. The only thing is you have to find the area of the base now. Okay, how to find area of the base? Just see this. So total surface area, we are going to add these 4 surfaces. First, the outer curved surface area, then the inner curved surface area, and we have to add area of both the bases. So we'll say, look at these 2 bases. Okay, we'll add 2 multiplied by area of base. There are 2 bases, the 2 multiplied by area of base. Now out of the 3 factors, we know the outer curved surface area and inner curved surface area. The only thing we are finding here is the area of the base. Let us find area of the base now. Okay? Just see the base carefully. Now if you see the area of the base, it is like a circle, but not a complete circle. Okay? Just have a look at, just try to understand this in detail. Let's take a solid circle first. Okay? So if I take a circle like this is a circle. Now to find the area of this circle, it is easy. We use pi r square. But if we have a figure like this, let's say like this. अब ये जो रेड पार्ट है ना, रेड पार्ट, ओके, ये जो रिंग जो आपको दिख रहा है उसका एरिया कैसे मिलेगा? So what we will do here is to find out the area of the boundary, or we can say the area of the ring here, we have to first find the area of the inner circle. आपको पहले पूरा सर्कल फाइंड आउट करना पड़ेगा. Sorry, the bigger circle. We find area of the bigger circle, and from that we'll subtract this inner circle. ये जो inner circle आप देख रहे हो ना, इसको आपको माइनस करना पड़ेगा. So the area of this figure that we can see here is area of outer circle minus area of inner circle, and then you get the boundary, or we can see the ring. All right, same is the base of this cylinder. So here is the most important thing. Area of the base here is going to be area of outer circle minus area of inner circle. Okay, write on this formula everyone. Area of the base is equal to area of outer circle minus area of inner circle. Okay, area of the base is area of outer circle minus area of inner circle. Now it is very easy. Let's use the formula. When we say circle, the formula is pi r square. The outer circle will have radius capital R and the inner circle will have radius small r. So let's do it. Formula for the circle is pi r square. So write down pi capital R square minus pi small r square. Pi r square minus pi r square. Now we can take this pi common, and in the bracket we will write r square minus r square. So we have this pi common, bracket r square minus r square. And then we'll substitute the values, which will give us 22/7 in the bracket, 2.2 square. The capital radius is, or the outer radius is 2.2, and the inner radius is 2. 2.2 square minus 2 square. Fine. Now in the bracket, you have to actually do the squaring, 2.2. You have two options. Either you can go for squaring 2.2 square minus 2 square, and then you will get the answer. Or you can use the formula a square minus b square. You can use the algebraic identity for a square minus b square. Okay, that will be a little easier for calculating. So we'll calculate this. It will be 22/7 multiplied by, we are taking the square. 2.2 square is 4.84. 22 square is 484. We adjust the decimal point, it becomes 4.84 minus 2 square is 4. So 22/7 multiplied by bracket 4.84 minus 4. So just subtract that 4. So we will get 22/7 multiplied by 0.84. And it is divisible now. 0.84 is divisible by 7. Let's do that. Okay, again, Janvi has again given me the answer. Let's see what the answer is. So here we can just do that cancellation by 7. 7 1 the 7 and 7 2 the 14. So 12 the hoga, 7 12 the 84. But it will be 0.84. Sorry, 0.12 when we do the division. It is 0.12. So the last multiplication that we have to do is 22 multiplied by 0.12. Okay, 22 multiplied by 0.12. So 22 to the 44, 4 will be carried. 22 1 the 22 plus 4 is 26. The 264. Okay, and then there should be decimal. The 2.64. So write down this. Area of the base is 2.64 centimeter square, and that will be the final answer. So we have got area of the base. Area of the base is 2.64. The final answer will be total surface area. So now we have to add these parts. So write down this. Total surface area is equal to outer curved surface area plus inner curved surface area plus 2 into area of base. Okay, so these numbers you have to add. So the total surface area is curved surface area, that is outer curved surface area plus inner curved surface area plus 2 times area of the base. So we have all the numbers. Outer curved surface area is, we calculated 1064.8. Inner curved surface area we calculated 968. Area of the base was 2.64, but it should be multiplied by 2. So 2 into 2.6. So we add them. So 1064.8 plus 968 will be 2032.8. The first two numbers when we add, these two numbers when we add, it becomes 2032.8. Now 2 into 2.64 will become 5.28. So 2032.8 plus 5.28. Okay, now we have to do the addition. Now I have to be a little careful here because in the first digit or on the first part we have only one digit after the decimal. It is 2032.8, but in the second part we have 5.28. So the decimal you have to be a little careful about that when we add. So when we add this, we get 2038.08. And since this is surface area, it will be centimeters square. Now this is the final answer. Write down this. Total surface area is equal to 2038.08 centimeters squares. All right, let us take one more exciting question from the exercise 13.2, which is question number 9. Let's understand this question first. The question is, find the lateral or curved surface area of a cylindrical petrol storage tank that is 4.2 meter in diameter and 4.5 meter high. How much steel was actually used if 1 upon 12 of the steel actually used was wasted in making the closed tank? So here they are having a cylindrical tank, okay, petrol storage tank. It is a cylindrical tank. We know it is 4.2 meter in diameter and 4.5 meter in height. So we know the diameter and the height. These are the two things we always require. We have to understand how much steel was used. So it is made up of steel. Okay, it is made up of steel, or we can say it is made up of steel sheet. Okay, it is made up of steel sheet. Again, while making anything out of steel or out of cardboard or anything, there is always some wastage. Okay, so let us say if you're making something, if you're making, let's say, a cylinder or a cupboard or any object whose area is, let us say, 100 centimeter square. But to make that 100 centimeter square, there will be some cutting, there will be some wastage, and we'll waste something more than 100. So for making an object of surface area 100 centimeter square, we may require 110 centimeter square because there will be some wastage. Okay, even when you do any your craft project, okay, जब आपका स्कूल का कोई project होता है उसको भी आप देखते होंगे, we cut few things, we waste few things, right? So there's always some wastage. So here also the wastage is 1/12 of the actual steel used. So let's first note down the dimensions of the cylinder, which are diameter and the height. So since diameter is 4.2, we get the radius. So let's write radius is 4.2 upon 2, which will be 2.1 meter, and the height is 4.5 meter. So we know the radius and height. Okay. Now we have this cylinder is to be made up with steel, and we have to find out the lateral or curved surface area of the steel first. We have to first find out the lateral or the curved surface area, and then we have to find out the steel used. So there are two parts. So first, let us find the lateral surface area, which is going to be straightforward formula. So lateral surface area is 2 pi RH. Okay, lateral surface area is 2 pi RH. Let's do this calculation all of you quickly. So it will be 2 multiplied by 22 upon 7 multiplied by 2.1 multiplied by 4. Get this done, all of you. So we can just divide that 2.1 by 7. It will give us 0.3. 2 into 22 into 0.3 into 4.5. Okay, who has got the answer? Bhavandana has got the answer. Okay, let's see. Now, 2 into 22 is 44. 0.3 into 4.5 will be 1.35. It depends upon how we multiply. You can just change the order of multiplication, no problem. So I have multiplied here 2 into 22, that is 44 into 1.35. Do this all of you. 44 into 1.35. Get this. The Janvi has also got the answer. So 44 into 1.35, we get 59.4. So this is the lateral surface area of the cylindrical tank. Write down this first part. Lateral surface area is 59.4 meters square. That's the first part. Okay. So this is the lateral surface area. Now understand the second part. How much steel was used if 1 upon 12 of the steel actually used was wasted in making the closed tank? Understand this now. We have to calculate amount of steel used, or that is we can say the amount of steel sheet used. The surface area is required, and it is also mentioned it is a closed tank. So to create a closed tank out of steel sheet, we have to consider its total surface area because it is closed. So हमें इसका total surface area use find out करना है. Remember, the steel used will be equal to the total surface area. जितना उसका total surface area है, उतना steel हमें use करना पड़ेगा. But there will be some wastage also. Okay, so since there is some wastage, we need to buy some extra steel. So if you are making anything of steel, and you know that you are going to waste some amount, so you will buy something extra. So we need to find a little extra. We need to have a little extra steel so that we can make that tank, tank comfortably. So understand this. Steel used in making the closed tank ideally. Okay, when we say ideally, what is the meaning of ideally? Ideally means without wastage. So we are first calculating the steel used in actual cylinder. So we are not considering the wastage. Okay, we are just finding the steel required to make the cylinder ideally without any wastage. So the steel used in making the closed tank ideally will be same as its total surface area. Okay, so we'll first find the total surface area, and then we will calculate how much is the wastage. So the wastage is 1 upon 12 times. Okay, so let us first find out this. Steel used in making the closed tank ideally is total surface area of the tank. So basically we are just finding the total surface area first. So let's use the formula. Total surface area of cylinder is 2 pi r in the bracket r plus h bracket closed. Let's calculate this. 2 into 22 upon 7 multiplied by 2.1 in the bracket there will be 2.1 plus 4.5. 2 into 22 upon 7 into 2.1. In the bracket, it is r plus h, that is 2.1 plus 4.1. Here what you can do is, in this second last step, this 7 1 the 7 and 7 3 the, so that is 0.3. Okay. And in the bracket, when you add these two numbers, 2.1 plus 4.5, it will become 6.6. Okay. So we get the next step, that is 2 into 22 into 0.3 into 6.6. Okay. 2 into 22 into 0.3 into 6.6. So 2 into 22 is 44 and 0.3 into 6.6 is 1.98. So just multiply this now, all of you. 44 into 1.98. Get this calculation done. Two into 22, that is 44. 44 into 1.98. Okay, Rupa has given me the answer. Bhavandana Janvi has given me the answer. All right. Do this calculation, everyone. So the multiplication here will be 87.12 meters square. Okay, there should be a decimal sign. Okay, so the steel used in making the closed tank ideally is 87.12 meters square. This is ideal. Okay, so this is the steel which is actually required for making the cylinder without any wastage. अगर कोई wastage नहीं होगा तो इतना steel चलेगा. But if there is some wastage, so we will require some more surface area of the sheet. Okay. So this is without wastage. Now let us calculate how much is going to be the wastage. In the question it was mentioned 1 upon 12. So the steel used is equal to steel used in making the tank ideally plus the steel wasted. Okay, this is going to be the formula. Do not write this. We have to first calculate the steel used, steel wasted. Sorry. Okay, अभी steel wasted कैसे पता चलेगा हमें? It will be 1 upon 12 times the total surface area. So first write down this statement. Steel wasted. We'll calculate this first. Steel wasted is equal to 1 upon 12 of steel used in making the closed tank ideally. Or you could have directly said 1 upon 12 multiplied by the total surface area. Even that means the same thing. So the steel wasted is 1 upon 12 of steel used in making the closed tank ideally, or we can say 1 upon 12 multiplied by the total surface area. So here it is going to be 1 upon 12 multiplied by steel used in making the tank ideally, that is 1 upon 12 multiplied by our previous answer 87.1. So we have to reduce this factor now. 87.12 divided by 12. Do this division, see if it is possible, if it gets divided completely or not. Is it getting divided completely? Okay, Srupa has given me the answer. So it is 87.12 divided by 12, isn't it? It is divided by 12. So even if you try to divide it by 12 directly, the 12 7 the 84. 3 will be the remainder. Okay, so it will become 31. Then 12 to the 24. 7 will be the remainder. And 7 to 2. 12. 6 the 70. Okay, so we get 7.26. So this is the amount of steel wasted. Okay. So now we know two numbers. The actual steel that is used, ideally, and the steel which is wasted. So we calculated the surface area, the total surface area of the cylinder. This is the actual surface area 87.12, and we have also wasted 7.26. So the total steel that we require is going to be the addition of these two numbers. So let's do this. Steel actually used is equal to steel used in making the closed tank ideally plus steel wasted. So that will be 87.12 plus 7.26, which on adding gives us 94.38. So this is going to be our final answer. Actual area of the steel used is 94.38 meters square. So we have this 13.6 question number 1. In exercise 13.6 question number 1, the question is, the circumference of the base of a cylindrical vessel is 132 centimeter and its height is 25 centimeter. How many liter of water can it hold? Now this is a very simple question where we also have the conversion 1000 centimeter cube is equal to 1 liter. So it is expected, the answer is expected in liters. So when we say how many liters, we are actually finding the volume. So let's solve this. We know the circumference of the base of the cylindrical vessel and its height. So we have a cylinder whose circumference is given and whose height is given. See, the radius is not given, but you can calculate the radius from the circumference. Okay, so the radius is given indirectly. So we'll first assume that the radius is r and the height is h, and then we will find r, and then we'll find out the volume. So let's solve this. Let r be the radius of the base and the height of the cylinder, and h be the height of the cylinder. R is the radius and h is the height of the cylinder. So the height is 25. So we have h is equal to 25. The radius is not mentioned directly, but we have circumference. Okay. So remember the formula for circumference. Circumference of the circle, the formula is 2 pi r. Okay. and we'll use that formula. So write down circumference of base equal to 132 centimeter, and therefore when we use its formula we get 2 pi r is equal to 132 centimeter. Circumference of the base is 132 centimeter, therefore 2 pi r is equal to 132 centimeter. So from this we can calculate this r. So we'll put the value of pi now. 2 into 22 upon 7 multiplied by radius is equal to 132. Okay. From this, to find out the radius, we first shift this 7 on the right side. The 7 will go in the numerator and 2 into 22 will be in the denominator. So we will get r is equal to 132 multiplied by 7 upon 2 into 22. Do this division, all of you. Do this cancellation and tell me what is the radius you are getting. You can directly divide by 22 here. So we can see if you do it by 22, it will be easier for you. So 22 6 22 6 132 it is. Okay, 22 6 132. Now 2 3 6. So we get 3 into 7. 3 into 7, it will be 21. Yes, most of you have given me the correct answer. Yes, the radius is 21. So we know the radius is 21. Now once we get the radius, we have to now find how many liter of water it can hold. So whenever we say how many liter it can hold, so we are talking about capacity, and that capacity means the volume. So we have to find out volume of the cylinder now. Remember the formula for volume of cylinder? Volume of cylinder is pi r square h. Let's calculate. Volume of cylinder is equal to pi r square h. So volume of cylinder is pi r square h. That means 22 upon 7 multiplied by 21 square, that is 21 into 21 multiplied by the height, which is 25. In case of volume, we get r square, so there is an extra multiplication there. So we can now divide 21 by 7. So we get 7 1 the 7, 7 3 the 21. And then it is complete multiplication after this. 22 into 3 into 21 into 5. Get this multiplication done, everyone. So when we multiply this, we get 34,650 centimeter cube. 22 into 3 will be 66 into 21 into 25. So on multiplying all these numbers, we get 34,650 centimeter cube. But the question is not over here. It was asked how many liter of water can it hold. So you want the answer in liter. Okay, and we know the conversion, it is already mentioned in this question. Even if it is not mentioned, you should know this. 1000 centimeter cube is equal to 1 liter. Now our answer is 34,650 centimeter cube. So to convert the centimeter cube into liter, we have to divide it by 1000. So we'll write 34,650 divided by 1000, because 1 centimeter cube is going to be 1 upon 1000 liters. So 34,650 centimeter cube is going to be 34,650 divided by 1000. The unit will become liter now. So let's divide our answer by 1000. So 34,650 upon 1000 liters. Here you can cancel this 0. And it is 3,465 divided by 100. That will be 34.65 liters. So that's our final answer for this question. The vessel can hold 34.65 liter of water. So the next question that we have is exercise 13.6, question number 2. So the question is, the inner diameter of a cylindrical wooden pipe is 24 centimeter and its outer diameter is 28 centimeter. The length of the pipe is 35 centimeter. Find the mass of the pipe if 1 centimeter cube of wood has mass of 0.6 gram. So in this question we are having a wooden pipe. So we have already solved one question where we had a pipe. Pipe is a cylinder which is hollow from inside. Okay, so it will have a inner radius, outer radius. So same way it is mentioned in this question also, that it's a pipe, a wooden pipe. But in this question we have to find out its mass. So the question is dependent on mass. Now how to find the mass, that we'll see later. First let's understand the shape of this pipe. So it is the inner diameter is 24 and the outer diameter is 28. So we can find out the inner radius and outer radius. So let's do this calculation. For the cylindrical pipe, since the inner diameter is 24, so inner radius will be 12. So we'll note down this. Inner radius, we use the small letter r. Inner radius will be 24 upon 2, that is 12 centimeters. That's the first thing we get, inner radius. Let's quickly calculate the outer radius also. Outer radius, now the outer diameter is 28. So for outer radius, it will be capital letter R we will use. So outer radius is 28 upon 2 and that will become 14 centimeters. So we know the inner and outer radius of this pipe. Okay, the length of the pipe is 35. We already discussed whenever it is length of a pipe, it is equal to the height of the cylinder. So pipe is in the cylindrical shape, therefore length of the pipe is the height of the cylinder. Yes, this is our first question after the break. So height h is 35 centimeters. All right. So we have these are the dimensions: inner radius, outer radius, and height. And one more important number we have here, that is, we have to find the mass of the pipe if 1 centimeter cube of wood has mass of 0.6 gram. Okay. So let's write down this thing. Mass of 1 centimeter cube of wood is 0.6. Okay. Mass of 1 centimeter cube is 0.6. Okay. So these are the three things we know: the radii, both the radii, height, and mass of 1 centimeter cube. So we have to find out mass of the entire pipe. Now understand this. Here it is clearly mentioned that 1 centimeter cube of wood. Now when you say centimeter cube, now centimeter cube is the unit of volume. Okay. And remember, the volume is always proportionate, or we can say it is always directly proportional to the mass. Mass and volume are directly proportional to each other. Okay. So to find the mass, we have to calculate the volume of this cylindrical pipe. Okay. So understand this. The mass of this pipe, okay, will be equal to, first we'll calculate, we know the mass of 1 centimeter cube of wood is 0.6 and it will be multiplied by the volume of wood used in making the pipe. So it's a simple thing. We first find the volume, we multiplied by mass of 1 centimeter cube of wood, that is 0.6. So just find out the volume of the pipe multiplied by 0.6. Now how to get volume of this pipe? Now remember, it is not a solid cylinder. अगर ये solid cylinder होता ना तो सीधा हम pi r square h कर देते थे, but it is not solid, it is hollow, it is open from inside. ठीक है? So you remember we did that question where we calculate the surface, total surface area. That time we calculated the area of the base, outer surface, area of outer circle minus area of inner circle. So same way here, the volume of the pipe or the volume of wood used in the pipe, imagine it is hollow from inside, so we can't take entire volume. So volume of the wood used in pipe will be volume of the outer cylinder. Okay, the entire volume of the outer cylinder minus volume of the inner cylinder. This will give us volume of the wood which is used in making the pipe. Let's calculate this. Now for calculating this, remember, volume of outer cylinder will directly use the formula for volume of cylinder, that is pi r square h. For outer cylinder, there will be capital radius, capital letter R. And for inner, it is small letter r. So write down this thing. Volume of wood used in making the pipe, volume of wood used in making the pipe is equal to volume of outer cylinder minus volume of inner cylinder. Okay, so formula will be pi r square h minus pi r square h. Here we can take pi common and h common. Pi and h will be common. So in the bracket we will have capital R minus small r squared, obviously. So pi h in the bracket r square minus r square. All right, so we substitute the values. It will be 22.7 multiplied by 35 into 14 square minus 12 square. Okay, so we can just divide that 7 5 the 35. In the bracket we have 14 square minus 12 square. You can square the numbers and subtract, or you can go for the identity a square minus b square. Here the numbers are 14 and 12. It would be better if you go for a square minus b square. Even if you square it, that will still give you the answer. So 22 into 5 in the bracket we'll write 196 minus 144. So 22 into 5 into 196 minus 144 will be 152. Sorry, 52. So multiply this all of you. 22 into 5 will be 110 into 52. Let's do this multiplication all of you. So when we multiply, we get 5,720 centimeter cube. So 5,720 is the volume of wood. Okay, 5,720 centimeter cube is the volume of wood. But we have to calculate mass of the entire pipe. Okay, and we know mass of 1 centimeter cube of wood is 0.6. The mass of the pipe is equal to mass of 1 centimeter cube of wood multiplied by volume used in making the pipe. Okay, so it is equal to mass of the wood, which is 0.6, multiplied by 5720. Multiply this and the answer will be in gram. All right, so when we multiply this, we get 3,432 gram. That is the final answer for this. It is in gram. What we can do is, though this can be kept as the final answer, but mostly we write down the answer in kilogram. So 3,434 gram is the expected answer. This will still give the full marks, but we're converting it into kilogram, because in real life mostly we deal in kilograms. When it goes beyond 1,000, it is better to convert it into kilogram. So we'll convert this into kilogram by dividing it by 1,000. So it will be 3,432 divided by 1,000, and that will be kg. So 3.432 kg. That's the weight of the pipe, or mass of the pipe. Okay, this is the final answer. Mass of the pipe is 3.432 kilogram. Next question is 13.6, question number 7. Now this is also a very important question. The question is, a lead pencil consists of cylinder of wood with a solid cylinder of graphite filled in the interior. The diameter of the pencil is 7 millimeter and the diameter of the graphite is 1 millimeter. If the length of the pencil is 14 centimeter, find the volume of the wood and that of the graphite. Okay, now in this question, it is mentioned that there's a pencil, lead pencil. Now imagine a pencil, you must have seen it definitely. Okay, so if you see the pencil, you see there are two parts. The outer part is wood, okay, and the inner part is graphite. Okay, if you remove the graphite, you can see it is hollow wood only. Okay, so there are two parts. There is the wooden cylinder, which is the outer one, and then there is a graphite, which is solid. Okay, so here it is mentioned that the diameter of the pencil means the entire wooden outer diameter. The entire diameter of the wooden part is 7 millimeter, and the diameter of the graphite is 1 millimeter. Okay, so we know both the diameters. Length of the pencil is going to be 14, which is same. Lead as well as the wooden part, it will have the same length, 14 centimeter. We have to find the volume of the wood and that of the graphite. Wood and graphite दोनों का calculate करना है volume. Now in the previous question we calculated volume of the pipe. With the same logic, we can calculate the volume of the wood, because when you see wood, it is not completely made up of wood. The wood is going to be hollow, okay, because there is a wood and inside there is a graphite also. So to find the volume of the wood, we have to subtract volume of outer wooden cylinder minus inner cylinder. And for the graphite is not hollow, graphite is solid cylinder. So graphite can be directly calculated with the formula pi r square. So graphite to directly aayega, but wood ke liye we have to do that subtraction. All right, these are the two parts we have to find. So let's just note down the things that we know. We know both the diameters, 7 and 1. This one conversion also will have to do, because the diameters are given in millimeter and the length is given in centimeter. So you have to convert them in 1 unit. So write down diameter of the graphite cylinder is equal to 1 millimeter. Since the diameter is 1 millimeter, our radius will be 1 upon 2. But here it is 1 millimeter. So 1 centimeter is equal to 10 millimeter. So we have to divide by 10. So 1 millimeter is equal to 1 upon 10 centimeters. So write down this 1 upon 10 centimeters. Diameter of the graphite cylinder is 1 upon 10. So if you want the radius, we have to divide this 1 upon 10 by 2. So this will be radius. See, the radius R will be 1 upon 10 divided by 2. Now we are talking about the radius of the graphite, okay, or we can say the inner radius. So radius of the graphite is 1 upon 10 divided by 2. So we can write this as 1 upon 10 multiplied by 1 upon 2. 1 upon 10 multiplied by 1 upon 2. So this will be 1 upon 20. Okay? So this is the inner radius, we can say, or the radius of graphite. The radius of graphite is 1 upon 20 centimeter. Is this clear to everyone? Okay, now we can also find out radius of the wooden part. This was the radius of the graphite part, and now we'll find the radius of the wooden part. So the diameter of the wood is 7, or we can say diameter of the pencil is 7 millimeter. This will also be converted into centimeter. So it is 7 upon 10 centimeter. 7 upon 10 centimeter. Now to convert it into radius, we'll divide by 2 again. So radius, that is the capital letter R. Now this is also the outer radius. So the radius is 7 upon 10 divided by 2, which will be 7 upon 10 multiplied by 1 upon 2. Okay, 7 upon 10 multiplied by 1 upon 2. So that will become 7 upon 20 centimeters. So you know both the radii. Inner radius is 1 upon 20 centimeter. Outer radius is 7 upon 20 centimeter. The next thing is the length, which we take it as h. So length of the pencil h is equal to 14 centimeter. Length of the pencil is 14 centimeter. Okay. So we have to find both the volumes. Huh? And yes, I already told you that the length of pencil and graphite is going to be the same. So h is common for both the parts. So length of the graphite is also the same. You don't need to write this separately. H is common for both of them. So whether it is for pencil or whether it is for graphite, H is the same, which is 14 centimeter. So length of both the parts, wooden part and the graphite part, is 14 centimeter. Now we'll try to find the volumes. We have to find the volume of wood and the volume of graphite. It would be easy to find the volume of graphite because it is direct calculation. So we'll first find the volume of graphite. Let's do that. The formula for volume of cylinder is pi r square h. And remember, in case of graphite, we are using the inner radius. So that will be small letter r. We have already mentioned that radius of graphite is small letter r, which is 1/20. Let's calculate the volume. Volume of graphite cylinder, pi r square h. Solve this, all of you. Volume of graphite cylinder is pi r square h. That is 22/7 into 1/20 into 1/20 into 14. The length is 14. Do this calculation, everyone. We can divide first 7 and 14. It's simple division here. 7 to the 14. Then 2 10 the 20, 2 11 the 22. We divided by 2. 22 and 20 divided by 2. Again 2 and 20. 2 1 the 2, 2. It would have been better if we had cancelled that 2 10 the 20. अगर वैसे भी तो और easy होता. Okay, anyways 2 5 the 10 भी किया तो भी चलेगा. So 11/100 हो जाता है ये. 11/100. Now 11/100, we just put the decimal 0.11 centimeter cube. Now this is the volume of graphite cylinder. Okay. So we know the volume of graphite is 0.11 centimeter cube. We have solved the second part, graphite. Now we'll come to the first part, that is volume of wood. Okay. We know the volume of graphite now. Now to find the volume of the wood. Okay. So when you talk about wood, we have to remove the volume of graphite from it. When you find the volume of entire pencil, you remove the volume of graphite. Now you have two ways of calculating it. Either you can do it like the previous question where we calculated the volume of pipe directly by writing volume of outer cylinder minus volume of inner cylinder, like that you can do. Or because we already know the volume of graphite, we'll directly find out the volume of entire pencil, and whatever answer we get from that, we'll subtract 0.11, which is the volume of graphite. Okay. So the wood is the part of the pencil excluding the graphite. So you can directly calculate the volume of pencil here. Okay. So we know that volume of wood is like this, volume of pencil minus volume of graphite, isn't it? Out of which we know volume of graphite is 0.11. So the only thing we have to calculate now is volume of the pencil. Let's calculate volume of the pencil. When we say volume of the pencil, it is pi r square h, where r is the capital letter, outer radius or the radius of the wooden part. Volume of the pencil is pi r square h, where r is capital letter. Let's substitute the values. 22/7 multiplied by 7/20 into 7/20. This is the radius. Multiplied by h is the length, that is 14. Again, we have same type of calculation here. 7 gets cancelled with 7 directly. 2 and 22 and 20 can be divided by 2. So 2 tens are 2 11s are 2 tens are 20 and 2 11s are 22. Now 14 and 10 can also be divided by 2. So 2 5s are 10 and 2 7s are 14. In the numerator we have 11 into 7 into 7. In the denominator we have 5 into 20. So now there is no division possible directly. So in the numerator 11 into 7 into 7, that is 11 into 49. So 11 into 7 into 7, that is 11 into 49, will give us 539. Okay, so 539 upon the denominator was 5 into 20, that is 100. So 539 upon 100, we get 5.39 centimeter cube. So this is the volume of wood. Okay, this is the volume of wood. Sorry, this is the volume of entire pencil, not wood. This is the volume of entire pencil. Okay. Now, if you only want the volume of wood, so what you do is you take volume of pencil and you remove the volume of graphite from it. So write down this. Volume of wood is volume of the pencil minus volume of graphite. Volume of wood is volume of pencil minus volume of graphite. Okay, just put both the numbers. 5.39 minus 0.11. A very simple subtraction here. Okay, 5.39 minus 0.11, we get 5.28 centimeter cube. Okay, write down the final answer now. Volume of the wood is 5.28 centimeter cube. Now let us learn about the next object, that is right circular cone. This is the geometrical figure of right circular cone. Okay, you can also give me a few examples. Imagine right circular cone. What can be the examples of right circular cone? So you have just seen this formula now. So for the cone, the slant height is L, and this slant height is actually, there is a relation between L, R and H because it is forming a right angle triangle. So we can say L square is equal to R square plus H square. Now this first formula can be used for finding the length, the slant height when we have radius and height, or if we have, let's say, radius and slant height, we can find out the perpendicular height. Or if we have L and H, we can find R. So this first formula can be used for finding any of the three. So if you have two numbers, you can find out any one missing number. Okay. So the slant height L square is equal to R square plus H square. किसी भी के लिए आप इसको यूज कर सकते हैं. The next formula is curved surface area, that is pi r L. Third formula is total surface area, pi r r plus L. And volume 1 upon 3 pi r square H. We'll be using these formulae whenever we have a question based on cone, a right circular cone. So let's take few questions now. So we are taking this question 13.3, question number 2. In 13.3 we have questions based on surface area. So let's see the first question. The first question that we are solving from 13.3. So this is 13.3, question number 2, that says find the total surface area of a cone if its slant height is 21 meter and diameter of the base is 24 meter. So it's a simple question where we have to find out the total surface area, where we already know the height and diameter. So let's write the slant height we have here, L. So whenever there is slant height, we say L. L is 21 meter and we have the diameter. Now diameter is 24, that means we can find out the radius. So the radius will be 24 divided by 2, that is 12 meters. So when we have the slant height and the radius, yes, slant height and radius both are there, we have to find out the total surface area. Let's use the formula that we have just studied. The formula for total surface area is pi r r plus L. Let's use that. Total surface area of the cone is equal to pi r r plus L. So it is 22 upon 7 multiplied by 12 multiplied by 21 plus 12. Okay, so here we have to solve this bracket first. We have to do this addition. There is no cancellation possible because 12 and 7 cannot be cancelled. We cannot divide 12 by 7. So let's add the numbers in the bracket. So 22 upon 7 into 12. In the bracket 21 plus 12, it will become 33. Still there is no calculation, there is no division possible. So the only option we have is multiply all the three numbers, 22 into 12 into 33, and then divide it by 7. Let's multiply this, all of you. 22 into 12 into 33. So either you can multiply, you just multiply these numbers, whatever answer you get, you divide it by 7. Okay, whatever multiplication you get, you divide that number by 7. Or you can, even if you divide directly 33 and 7, you'll get the answer in decimal. Any which way you're going to get it in decimal. Do this multiplication, everyone. See, if you multiply this, if you multiply these numbers, you will get 8712. Okay, 8712, and you have to divide it by 7. Okay, and when we divide this by 7, we'll get the answer as 1244.57, something like this we get. Okay, when we divide this by 7, this can be done. Okay, 1244.57. This is when you multiply all the numbers. Or if you don't want to multiply, there is one more way. Again, you're getting decimal. What you could have done is 7 3 the 21, then 7 7 the 7 1 and 7 4 the. So when you divide 33 by 7, you get 4.714, and then you have to multiply. See, even in this case also there is a decimal and there is multiplication. So better we multiply all the numbers and get it. So this is our final answer. 12.244.57 meter square. We have written approximately because even after 57 there are few digits, so we have ignored those digits, so we have written up to 2 decimals. So the total surface area of the cone is 1244.57 meter square approximately. The next question that we are solving is exercise 13.7, question number 7. Now this is also a slightly different but very interesting question. Let's see the question. A right angle triangle ABC with sides 5 cm and 12 cm and 13 cm is revolved about the side 12 cm. Find the volume of the solid so obtained. Let's imagine this thing. We have, let's say, a cardboard triangle or triangular cardboard we have, and we rotate it. So when you rotate this triangle, it will look like a cone. It will look like a solid cone. Like we see fan. Fan has 3 blades. When it rotates, you see as if it's a circle, isn't it? Same way, when we have this thing, when we have this triangle and when we rotate it. Now understand the rotation. The rotation is about the side 12 centimeter. So the 12 centimeter is going to be the axis. Now just see this figure here, all of you. In this figure, 12 centimeter side is going to be the axis. Okay, so we have to keep that size 12 centimeter fixed, and we have to rotate it around this 12 centimeter. So just look at that point C, it will be revolved. Okay, so this triangle we have, and we'll rotate it like this. Just see, this 12 centimeter should be fixed, and we'll rotate it like this. Like this it will rotate. Okay, so it will rotate. Fine. So it will rotate, it will come here, it will come here, it will rotate like this, and it will look like a cone. Okay, so when we consider the rotation, it will look like a cone. Okay, and we just have to find the volume of this cone. isn't it? Now you see, in this cone, we can easily see that the radius is going to be 5 centimeters and the height is 12 centimeter. So because we know radius and height, we can easily find the volume of this cone. So calculation is not difficult here, but you have to understand when we rotate this triangle, how a cone is formed. And the most important thing is the triangle is rotated about which side. So the triangle is rotated about the side 12 centimeter, that is AB. So I want everyone to draw this figure because this figure plays a very important role in this calculation of this question. Okay, so let's draw this triangle, all of you. There should be a triangle ABC, and because we have rotated it, so we'll take that point C1 and it will form a cone. So let's see this. A solid object, the solid object form is the cone. So first, on revolving the right triangle ABC about the side AB, that is 12 centimeter, we get a cone as shown in the figure. We will write on this thing in our answer. Okay. So on revolving right angle triangle ABC about the side AB 12 centimeter, we get a cone as you can see in the figure. Now this cone will have the radius and height, and we'll calculate the volume. So the volume is 1/3 pi r square h. Before that, we should write down the radius. So let's write radius will be equal to 5 centimeter. Okay, and height will be equal to 12 centimeter. Okay, the radius will be 5 and height will be 12. So let's do this calculation, all of you. Volume of the solid so obtained is 1/3 pi r square h. Volume of solid so obtained is 1/3 pi r square h. So 1/3 multiplied by 22/7, or just pi at this stage, and then 5 into 5 into 12. So we can divide that 3 4 the 12. So we get 100 pi centimeter cube. So the volume obtained is 100 pi centimeter cube. Here, since the value of pi wasn't mentioned, in our other questions, it is mentioned that to take pi as 22/7 in the exercise 13.2 and 3 also. But in 13.7, it wasn't mentioned directly. So our answer here will be 100 pi. If the value of pi is mentioned, if it is, let's say, 22/7, we'll multiply this into 100 into 22/7. Or if it is 3.14, we'll write 100 into 3.14. If any of the value is given, we'll do substitution. Otherwise, we'll just keep it in terms of pi. So this is our final answer. Volume of the solid so obtained is 100 pi centimeter cube.